Good evening and welcome. I'm David Wood from the Pacific Science Centre, and I'll be your host for tonight's Science in the City live stream. Thank you for joining us. I'm coming to you live once again from my bedroom here in Seattle, but we really appreciate you joining us and connecting with us this evening. Before we start tonight's talk, I'd like to share a few bits of information with you all. We've uploaded some of our past Science in the City talks to YouTube. That includes our talk we did on 420 titled, What Are You Smoking? Demystifying Cannabis Regulations and Testing, with our friends over at Confidence Analytics, which is an accredited cannabis testing laboratory here in Washington State. 2 days later was Earth Day, and so we were joined by Dr. Peter Kahn, who is an eco-psychologist at the University of Washington. He had a talk titled Earth Day, Now More Than Ever, Into Nature and Toward Life. And most recently, we've uploaded last week's Science in the City talk titled Pizza, Robots, and Restaurants of the Future. Who doesn't love pizza and robots? Where we were joined by Clayton Wood, who's the CEO of Picnic, which is a local startup here in Seattle where they've developed a robotic pizza production platform. So for those past talks, plus a number of others, head over to the Science in the City tab on PacSci's YouTube page. You're already there. Obviously do so following tonight's talk. Don't do it now. We've got some excellent upcoming Science in the City talks for you. Those are going to be on Tuesday evenings at 7 p.m, same time, same place. Upcoming talks include The Reality of War in Outer Space. We're going to be joined by Dr. Sadia Pekanen, who is the co-founder at the University of Washington Space Policy and Research Center. That's going to be next Tuesday, May the 27th. Dr. Pekanen will be discussing why the trends of democratization, commercialization, and militarization may indicate a path towards conflict in space. So it's no longer in the realm of science fiction. The topics don't get any friendlier. The week after, that's going to be Tuesday, June the 2nd, we will be discussing murder hornets. We're joined by Dr. Chris Looney, who's an entomologist at the Washington State Department of Agriculture. They're recently quoted in a great New York Times article. The title of that talk is 2020 Strikes Again, Murder Hornets. Obviously, murder hornets is the nickname for the species. The common name is the Asian giant hornet. So Dr. Looney will be discussing why literally the largest hornet in the world, talking to us about the basics, also the risk that they pose to local wildlife and our economy, and current efforts to eradicate the pest from our region. So to stay in the loop about all of our upcoming Science in the City talks, obviously those are just an example of the two upcoming ones, and to stay connected with local scientists and experts, sign up for our e-newsletter at pacsci.org/SITC. That's for Science in the City, pacsci.org/SITC. Educational programming like this is made possible in part thanks to the generous support of our donors. In the face of challenges like COVID-19 and climate change, science and an informed public are absolutely essential. So to help us ensure that curiosity never closes, or for more information about donating to the Pacific Science Center, visit pacsci.org/support. So on to tonight's event, we are joined by Dr. Abund Lesiak. They're Director of Education and Outreach at the Department of Genome Sciences at the University of Washington. Abund's a neuroscientist, but they're also a member of PacSci's Science Communication Fellowship Program, which offers training and support for local STEM professionals and connects their work to public audiences. Abund's going to be discussing why our brains are hardwired to want more of the things that make us feel good. For me, during quarantine, what makes me feel good is maybe watching some old soccer matches, a bit of England, obviously some ones that they've actually managed to win. I've also been enjoying eating lots of homemade chocolate chip banana bread. Speaking of which, Abund will be discussing why our bodies need sugar, obviously in the form of glucose at its most basic. And in order to, obviously we need to consume that in order to stay alive. But why are we drawn to consume more than we really need? And can sugar really be considered addictive? So tonight, Abund will discuss the neuroscience of addiction and the potentially addictive properties of sugar and the impacts that can have on our health. If you have a question for Abund during the presentation at any time, please leave your questions, your comments, your thoughts. Let us know how you're doing today. Let us know if you've been enjoying a sugary treat during quarantine. Please leave all of that in the YouTube comment section, and we'll try and get to as many of those as we can during the Q&A. So without further ado, please welcome to the live stream. Oh, you're already here. Hey. Dr. Atum Lesiak. Atum, how you doing?
I'm doing great. Thank you so much. I'm very excited to be here tonight. So I'm going to get the presentation started. I hope you got your popcorn or whatever you need ready, and we will begin. As long as I don't get signed out of Zoom. Okay, here we go. Thank you for bearing with me. So tonight I'm going to be talking about sugar addiction. So my background is in neuroscience. I just recently last year ended my postdoc as a neuroscientist, where I was working a lot with the Pacific Science Center, doing science outreach. And now I'm with University of Washington's Genome Sciences Department as the Director of Education Outreach. So my job is really to talk about research and science and share that with the public full-time now. And I'm really enjoying that job. Tonight with sugar addiction. So I want you to start off by thinking about what your favorite sweet treat is and how it makes you feel. And you know, you probably can't remember the first time you had a really sweet treat. So we have this baby here to highlight what that's like. And so the baby takes a little bite of ice cream, and immediately you can see the baby's eyes light up and grab that ice cream. So excited to have a little bit of that sweet sugar rush from that treat. Just a classic video there. And so tonight, really, we're going to be asking a few questions and just talking about sugar. So first of all, what is addiction? I think we need to set that before we can talk about whether sugar may or may not be addictive. And then we're going to dive into that controversy over why some people think it is, some people think it isn't. And then I'm going to place sugar in the historical context of how much sugar we're eating today versus how much sugar our bodies were intended to consume early on within human history. And then lastly, end with why sugar is such a big problem in modern society. So first off, what is addiction? So a lot of the research that I was doing as a neuroscientist was addiction research. And the language around addiction can be very complicated and oftentimes is hung up in certain kinds of semantics around which kind of words and what is or is not addiction. But simply put, and this would be a National Institute of Drug Abuse definition, is addiction is when one obsessively is obsessive about and compulsively uses, and they say, drugs and alcohol despite negative consequences. Why alcohol is different from drugs? A little curious, and why the focus on drugs and alcohol, I'm not entirely sure. But generally, it's characterized by tolerance, withdrawal, physical cravings, and emotional obsession. And there's three key components, which is loss of control, impairment, and relapsing. So we're going to dive into those. So loss of control is you can't stop yourself from taking more. Impairment is it impacts you in some way negatively. And then relapsing is that it, after abstaining for a while, you're oftentimes drawn to take more of it afterwards. And again, there's a big focus on drugs and alcohol, but honestly, I believe that other things can be addictive as well. And we'll talk a little bit more about that. So oftentimes when we think about addiction, we think about substances. We think about nicotine. We think about drugs of abuse. We think about alcohol. We think about pills. But more recently, we also can talk about addiction to our devices, addiction to playing video games, and other things maybe like addiction to money, gambling, or even addiction to love and interpersonal connections. And one thing that all of these have in common is they impact our brain in some way. And so really, one of the ways that I understand addiction is by thinking that addiction is a problem of our brains being too good at adapting to things that we like. or just adapting to anything in that nature. So for example, if you live in a noisy neighborhood, your brain adapts to the level of noise so that all the noises that are happening around you don't constantly bother you and make you change your attention to those things. Your clothes, you adapt to the touch of your clothes on your skin so that you're not constantly aware that your shirt is on your body. At night, when you're in the dark and then somebody shines a light in your face and it hurts, you were adapting to that low light level, and then you're overwhelmed by the stimulus of the light. And then also when you're eating something that's really sweet, that first bite is glorious, and the last bite, you savor it, but it doesn't quite taste as good as that very first treat because you adapt to that sensation. And so when we look at what is actually happening in the brain, we have to understand how the brain is networked together. So when we break it down into the individual cells, these individual brain cells called neurons are interconnected and send signals back and forth. And the messages being sent is what creates thought, actions, and feelings inside of our body. And so the process of adaptation, whenever I talk about that, I like to say that neurons are a little bit like trees. And so trees are on the right here, and we've got a neuron on the left. And on the tree, we've got the branches. And on the neuron, we have the dendrites. And so along those connections, we have these little, we have the leaves that receive signals. And the signal that they receive is going to be sunlight, whereas the dendrites are going to be receiving signals from other neurons. And when we think about those, them being interconnected, when one neuron signals onto another neuron repeatedly, the neuron on the left here is like, that's great, let's make more connections so that we can get more of that signal. And you will actually grow new connections and make that signal transfer stronger. And so one of the neurochemicals inside the brain that is really good at stimulating brain activity and increasing those connections is called dopamine. And so one of the things, dopamine's reputation is that dopamine makes you feel good. And so it resides in the center of the brain. In its chemical structure, it's not very big, and it makes you feel good. So dopamine is essential for the cycle of addiction in which you do something. So we take a drug, or we play some video games, or you name it, we do something. And then that makes us feel good. We get a little puff of dopamine inside of our brain. And when that happens, we feel good. So then that encourages our brains to make us want to do more of that thing. And so we do more of that thing, which makes us feel good. And that cycle continues until, well, the brain adapts to that good feeling. And then doing that makes you feel less good. And then less good. So then you're craving to do more and more of that thing so that you kind of return back to the good feeling that it initially gave you. So you have to do more and more and more, and you feel good again. But then slowly over time, as you do more and more and more, you crave doing more because you want to get back to that same sensation that you had, and it feels less and less good. And so you have to keep consuming more in order to keep up that same level of dopamine inside of your brain, because the neurons grew together and made a stronger connection. And unfortunately, with withdrawal from something that makes us feel good, oftentimes we'll get that dopamine crash, which is generally more severe with drugs, and you go through withdrawal and you feel absolutely awful. If we block dopamine within your brain, you're not going to feel good. Okay, so now the symptoms of withdrawal. Oftentimes we're associating this with drugs of abuse, which are affecting our brains, but as well as our bodies. And so with drugs of abuse, oftentimes we get exhaustion, vomiting, seizures, insomnia, pains. Oftentimes withdrawal from drugs can be lethal, especially if somebody is highly addicted to alcohol. And sugar has a lot of the similar symptoms of withdrawal, although they're not quite as severe. So oftentimes when I am really wanting something sweet, I get a very intense craving for that. Oftentimes I'll feel irritable if I don't get it, and I get a little depressed as well. Again, Sugar withdrawal does not seem to be as severe as those of drugs of abuse, but there's a good reason why for that. So once our brains have adapted to that strong signal from the thing that makes us feel good, our brains tend to want more and more of that signal. So things like sugar, exhilarating experiences, taking time, doing yoga, exercise, gaming, dancing, right? Our brains, when we get a good experience from that, we want to do more of it, and our brains will increase the connections. But the big difference between these things that are considered to potentially be addictive and drugs of abuse is that these drugs of abuse artificially stimulate levels of dopamine to a level much higher than we get from these other stimuli. And also, oftentimes drugs have negative impacts on other parts of our body. So the side effects of that is a lot higher, as well as having impairment, poor sense of judgment, and things that go along with taking drugs of abuse. And so oftentimes people will say, well, is caffeine addictive? And well, it may or may not be addictive, but we do get a tolerance to it. So then we have to take more and more in order to get the same rush from it. And interestingly, caffeine oftentimes works in conjunction with other things that stimulate dopamine and enhance that dopamine experience. So one of the things that's really popular right now are these Red Bull cocktails or frappuccinos that have coffee and sugar and high amounts of fat. And you can imagine that if you were to give this baby one of those substances, its eyes would probably bug out even more in response to something that's that delicious and that's stimulating with the caffeine. So we're going to come back to, is sugar addictive? A lot of people will say no. And for a simple reason of that sugar is needed for survival. So sugar is within most of the foods that we eat, whereas we don't necessarily need these other stimuli to survive. So apples, broccoli, bread, meats will all have sugar in some form or another, whether it's simplified sugar compounds or long chains of sugar. Most things have sugar in it. And if we don't have sugar in our bodies, we don't have the energy we need to run our bodies, and we will die. Right? We don't need these other substances necessarily to survive. And so people say you can't be addicted to a thing that your body absolutely needs to survive. Again, potentially semantics, because in the end, the difference between the amount of sugar that we're eating, say in an apple, 19 grams, and the sugar that we're experiencing in an ice cream cone is pretty different. There's about twice as much ice cream or sugar within an ice cream cone than there is in an apple. If you eat a drink a soft drink or eat a donut, there's a lot of sugar in that as well. But there is sugar in healthy foods as well. And so it's not only the amount of sugar that we have within our modern diet. This is a great visual of how much sugar is in a soda. You can see that not only is there a ton of sugar, but it's in liquid form, and that makes a big difference. Because when we think about how the sugar gets into our bloodstream and stimulates that experience of having sugar in our bodies, you can also consider about how fast the sugar is entering into the bloodstream. So with a soda pop, if you drink it, goes into your stomach, then into your intestines, that sugar was ready to be absorbed into your body as soon as you drank it. And so the sugar from the soda pop gets into your bloodstream really fast. And you can say that's a little bit like injecting sugar into your bloodstream. It's a very fast process. And so if you compare that to an apple, you have to chew the apple, then your body has to digest the apple, break it down into smaller pieces before you can actually absorb it into your body. So the sugar in the apple comes along with fiber that slows the uptake of sugar into your bloodstream. And so even if the soft drink and the apple have the same amount of sugar, the time that it takes to get into your body takes a lot longer. And that's actually much healthier for your body and probably has less of an effect on stimulating that dopamine burst in your brain. And so I think of like apples or like whole fruits that have sugar more like taking a pill. And so injecting a drug like heroin versus taking Oxycontin within a pill form, the addictive properties of those two ingestion methods is very different. And I think that's probably the case along with the way that we get sugar in our diet. So bigger and faster dopamine bursts will likely happen with processed sugar. All right, so the other thing about the way that we're consuming sugar nowadays is that we process a lot of our foods to make them more readily edible. If you've ever tried to eat a raw potato, that is hard. And it's hard for your body to break down the sugars in that potato to get it into your body. Whereas if you turn them into French fries, you cut them up and you cook them, the sugar from the French fries gets into your body a lot faster. Same thing with grains. If we take those grains, we grind them up, turn them into flour, and then bake it into bread, that sugar has been broken down into smaller pieces, so it's easier for it to get inside of our bodies. And there is a theory out there that the cooking process of food is what's allowed us to get enough sugar to grow our brains and become more intelligent as Homo sapiens. So shifting focus a little bit more to research on addiction. So this is the kind of research that I used to do in the lab that I worked in. And on the left here, we have a rat in a cage who is pressing a lever to receive a reward. Oftentimes what we use with rats is injections of cocaine, so that when they press the lever, they get an injection of cocaine, they feel good. And so if we look at the graph on the right, we can see the black dots are saline and the white dots are cocaine. And so this is the number of cocaine injections on the y-axis. And then this is the number of sessions that they get put into the box. And so what we can see is that with cocaine, the rats on the first session are like, okay, this is a new experience. But then slowly over time, they're like, I really like this. And then they really like this. And then they really, really like this. And then they max out the number of times that they can press the lever for cocaine over time. Whereas with saline, they're kind of like, all right, pressing the lever, that's just kind of their baseline. They just get bored in the box and they press the lever a little bit. So when we're doing research on rats and mice with regards to sugar addiction, it's a little bit different. We have found that rats actually do really like sugar and they will press that lever for sugar. I really like this cartoon that talks about the potentially addictive properties of Oreos. And so in this case, we have the same setup where instead of pressing for cocaine, the rats are pressing the lever for sucrose pellets. And you can see over time, they learn that when they get that press, they get the sugar. And then over time, they increase the amount of sugar that they're taking. And so one of the big caveats to this kind of research is that the dopamine that we get from those rewards, whether it's sugar or cocaine, is oftentimes dependent on our basal mood. So rats that are comfortably housed and not under stress will actually, if they get a choice between the sugar and the cocaine, most rats will choose the sugar reward rather than the cocaine. But if you put the rats under high amounts of stress and they're all stressed out, they will prefer the cocaine more so than they do to the sugar. And the idea there, it comes from ideas within human addiction research that people under high amounts of stress oftentimes will turn to things that give us a dopamine rush to bring our mood and our good feelings up from baseline. So if we're stressed out, the dopamine release in our brain might be low. So then we eat a cookie and we feel a little bit better. Additionally, if somebody is very stressed out or has a history of taking drugs of abuse, when they're very stressed out, they're going to go and look for the drug. When they take the drug, they get that giant dopamine burst, And then that makes the substance even more addictive because they're going from a low state to a high state. Whereas with sugar, you're going from a low state to a higher state, but not quite as high as you're getting from these unnatural substances. And so this is all leading up to one of the things that has really impacted me as I've switched from being an addiction researcher to education outreach with my group in Genome Sciences. So within the history of sugar production, early Homo sapiens was always tuned to enjoy sugary substances, but those sugary substances were hard to find. So maybe you'll stumble across a beehive, you get some honey, that's almost pure sugar. It's going to be absolutely delicious. And even if if you say stumble across some delicious fruit, not nearly as probably as sweet as the fruit that we've developed through through selection process. But if you stumble upon that fruit, it's within our biological makeup to want to consume as much of that fruit as possible to get as much of that sugar, because we don't know in the kind of prehistoric times when we're going to be able to find something that's that sugary again. So our body wants to consume as much of that sugar, and still today our bodies are tuned to love and to seek more and more sugar over time. And that's, I think, one of the problems that we're having, because sugar is not hard to find anymore. It's actually way more easy to find than fruit in many cases. And again, sugar was really hard to get. Sugar cane originated in New Guinea, made its way over to India, where they have the first written record of purifying sugar from sugar cane in 100 AD. And as soon as that started happening, sugar just became extremely popular among society. You can imagine if you go your whole entire life without having any sugar, and then all of a sudden you're tasting this very sweet treat of some sort, you're going to want more and more of it. But it was hard to produce, hard to distribute long distances. And so really sugar consumption was limited to the very rich and wealthy across the globe. Again, sugar was a precious resource, and human beings liked it so much, especially Europeans who were existing far away from the sugar. They liked it so much that they they started wars to go and get sugar, bringing back sugar to Europe, stimulating such a high demand for sugar that they went on to colonize the Americas to try to grow sugar on their own. All sorts of terrible things happened in that process, and in that desire for Europeans to get sugar, and slavery was a large part of that process of wanting to get more and more sugar. So there's a high demand. They were highly motivated to get as much sugar as possible. And so industrialization over time, human beings got really good at making sugar, purifying sugar, growing sugar. And with industrialization, we got more and more sugar. And it wasn't until 1966 that having too much sugar was actually recognized by the American Medical Association as being not good for you. And that's interesting because that seems to coincide with the significant increase in sugar consumption within our culture. And so in this graph, we can look at average sugar consumption in kilograms per individual in a year from the 1700s to the year 2000. And you can see 1700s, we get colonization of America here. And so again, this is from the United Kingdom and the United States. So we've got colonization here, all of a sudden, boom, we've got a giant increase in sugar production. And with that coincides with an increase in obesity prevalence over time. These wells here coincide with the World War I, World War II. And personally, when I look at this graph, I kind of look at some of these drug addiction research with rats, where we've got this significant increase over time of pressing the lever for cocaine injections. And so along with this significant increase in sugar consumption comes the prevalence of diabetes. So diabetes was thought to be just a rich person's problem historically. They didn't have a treatment for it. And through the late 1800s, early 1900s, it was pretty much, if you got diabetes, it was pretty much a death sentence because there was no treatment or no way of identifying and purifying insulin, which helps the body process sugar and get it into the body. And so diabetes is represented by inability to create insulin inside the body. And so what we see here is a significant number of deaths, then a large increase in the rates of diabetes over time. And this has not ended. It has only gotten worse over time. Oh, this is a nice visual for, I was wondering the other night, like, okay, how much sugar is 5 kilograms per year for an individual? And so in the 1700s, that averaged out to 1 4-pound bag of sugar per person per year. Still a lot of sugar, but if you think about how much sugar we're consuming, say in the late 1800s, early 1900s, that goes from 1 in 1700s to 22 4-pound bags of sugar per person in the 1900s. And then 2000, we have 38 4-pound bags of sugar per person. So well before 1700 is when our biology was tuned to consume a certain amount of sugar. And we have gone from eating much less than 1 of these 4-pound bags in a year now to 38. So the magnitude of our increase of sugar consumption has gone up dramatically. And this pops out to me since I've started doing diabetes education and outreach, that when talking to my grandmother about what her favorite Christmas memory was, and she would say, oh, we looked forward to Christmas every year because we would get an orange. And she's like, oranges were my absolute favorite. It was so delicious, so sweet, so good. And I'm like, an orange, like, and she's just like, that's what we looked forward to. And so you can imagine in her time, getting that orange, as a kid, that was like that baby tasting ice cream. You get an orange and you don't get very many oranges all that often. You get this giant dopamine burst because you're not used to having all sorts of sugary things. And I compare that to when I was a child. If my parents gave me an orange on Christmas, I was mad. I would not have gotten any dopamine. In fact, I would have gotten a big stress hormone response and I would have had a fit. And so part of that is because, I was a rather privileged child, and every Christmas I was expecting presents and sugar and candy. And every year I wanted more and more and more to get that same experience of that rush of having so many presents and so many treats. That's just, I was tuned to expect a very high level of sugar. And in addition, I'd been trained by my experiences as a kid of waking up in the morning, picking out which of these sugary cereals I wanted to consume. And while experiencing that rush of sugar, I'd watch something that would give me another dopamine rush. And so I'd get that combination of sugary cereal, exciting television shows, and everything that I ate in my lunches all had sugar added in because it just makes food taste better. When thinking about where sugar is in our diets, oftentimes we don't think about things other than like candy, baked goods, and sweets. Fruit juice has added sugar, yogurt has added sugar, barbecue sauces, it's everywhere, right? I thought through college I was eating a healthy diet of eating mostly granola bars. As it turns out, there's tons and tons of sugar in granola bars. And so over time, as sugar has become so prevalent in our society, we've just become used to it. For me, an orange just isn't that exciting anymore. I get excited when I pop open my freezer and I get some ice cream, or I bake a fresh batch of cookies. And for me, I was also really lucky as a kid that my mom was a wonderful, wonderful baker. And so we always had fresh cookies, cakes, you name it. And so from a very young age, I would associate these sweet baked good treats with love. It's something that's ingrained in our culture. When people came over to my house as a kid, we would offer them something to drink. And oftentimes that would be Coca-Cola, fruit juice, Kool-Aid, lemonade, always with sugar. It's ingrained in our culture, and we don't even oftentimes see all the different places that we're consuming sugar in our diet. And so oftentimes, because our sugar is just filled, or our culture is filled with sugar, we now have this very high risk of obesity and diabetes. And for me, I thought, I'm a neuroscientist, I'm a really smart person. I started this job as the director of education and outreach. I hadn't done a lot of diabetes research or talked about it all that much. And the more I talked about it, the more I realized like there is sugar all over the place. And I started reading the labels on the almond milk that I was adding to my coffee every morning, the yogurt that I ate every morning. I thought I had a very healthy diet, but the amount of sugar that I was consuming was off the charts. And my family has a history of diabetes, and that started to scare me. So I just started to look at all the different places that sugar was hiding in my diet. And I still consume a lot of sugar. So I'm not saying that it's an easy switch to make. When I'm stressed out, I turn to Scandinavian swimmers is like my special treat. I love those things. I can eat like a whole bag when I'm stressed out for sure. So it's not any surprise that in the past 20 years, as we've gotten really good at making extremely tasty treats, such as Scandinavian swimmers, we get this big increase in obesity prevalence across the country. And along with that, oftentimes will come diabetes. And so as a culture, we have a national sugar problem that is just related to overconsumption. And oftentimes we don't really talk about it. So I really like this graph because it talks about the actual causes of death for humans in the United States, what we're Googling versus what different media sources are covering. And so you can see people are not dying from terrorism all that much, but they're searching it on the internet and they're seeing it on the news quite a bit. Same thing with homicide, disproportionately covered in the media, but not in other sources. Cancer is underreported, but one of the leading causes, same with heart disease, but we're not talking about it. And so you can see here, we've got diabetes and drug overdoses side by side. From my perspective, I see these as kind of similar processes of overconsumption of substances that make us feel good. And I just want to clarify that I'm talking about type 2 diabetes. This actually does include type 1 diabetes, which is caused by very different factors. And so you can see once people get diabetes, they're Googling it, but not so much with drug overdoses. And this is something that really jumps out at me, is that as over time, the cost of insulin that people with diabetes need to survive, whether it's type 1 or type 2 diabetes, they need that in order to stay alive. Over time, the price of that insulin has gone up and up and up. Part of that is it's hard to make insulin, and keeping up with demand has been a challenge. And the Humalog insulin is actually produced by a single company. And so you can imagine if I'm a company that people need my drug in order to survive, the more people that need it, the more I might charge for it. And then as more and more people need it, I might charge more and more and more because they need it in order to survive. And that's why the cost of insulin has skyrocketed over time. And so we can talk about the semantics of what is addiction, what is addictive, what is not addictive. I would say that even, drugs of abuse, like, is it the drug that is actually addictive, or is it the feeling that we experience from the drug that is addictive? And so can we get addicted to a feeling, or is it to the substance? Why do some people that take cocaine get addicted? Why do some people that take cocaine don't get addicted? This is something that neuroscientists are trying to figure out. But regardless of the addictive properties of sugar, we are consuming too much sugar, and it is causing significant health risks to our society. And so, just to wrap things up, is sugar addictive? I'm going to let you decide, and I'm going to let the scientific community figure that out. But when I think about sugar and whether it is or it isn't, I just think about this baby's eyes as she takes that ice cream and her lights up to the point of just grabbing this cone. I can never forget that visual in my head. And with that, we're going to open it up to questions. I thank you all very much for sticking around for my talk.
Thank you so much for that, Adam. I know everyone at home really appreciates that presentation. The baby is also getting some love in the comment section. We had a comment saying that the baby video was a perfect example. So thank you for that. So obviously we're moving on to the Q&A now. If you're watching from home, again, you've got questions, you've got comments, let us know how you're feeling today. Let us know if you think peeps are an acceptable form of food. At the risk of letting the comment section go a little off the rails there, but please leave all of that below, and it's our job to try and connect you with Atom. So I'll start with some questions that have been submitted. Is there any research or evidence, or just your thoughts in general, on artificial sweeteners such as aspartame being worse than sugar in terms of its addictive properties? Because in some cases they're less sweet than, say, cane sugar.
Yeah. Well, so a lot of the artificial sweeteners, so within my group, the Genome Sciences Education Outreach, we have an activity for high school students where they taste different artificial sweeteners and then rate the sweetness of them. And so a lot of these sweeteners are actually more sweet. So on your tongue, you have sweet receptors that respond and send a signal to your brain in response to the chemical that normally would look like sugar, but in this case, they're chemicals that activate the receptor but aren't actually sugar. And so a lot of these artificial sweeteners are much sweeter than sugar, which is why you can put less of them in a beverage. But they also have weird aftertastes because they don't only activate the sweet receptors, they sometimes partially activate, say, a bitter receptor. And so food science is really keeping up with changing the chemical structure so that your body doesn't take in that extra sugar and try to turn it into energy. And also the breakdown of these chemicals and what that does to, say, the sugar receptors in your gut that are telling your pancreas to make insulin, that's still unknown. And there's all sorts of fun experiments that you can do with there's a tea called Gymnema tea that will block your sweet receptors. And it's thought to be an anti-diabetes drug because it prevents sugar from being absorbed into your gut. And I did an experiment for some teachers that we had, and I drank way more Gymnema tea than you ever should, and then took my blood glucose. And when I was doing the reading, I got really lightheaded and felt sick and almost had to go home because I was not supposed to take that much Gymnema tea. So yeah, it's those different compounds work in so many different ways. And I think we're still learning about how exactly they work and their effect on the body.
Curiosity can lead to weird and wonderful things, and laying it all on the line in the name of science.
Yeah, I'm not going to do that experiment again.
Lesson learned, maybe. We got some great comments. So What have you found is most effective to convince people to get off sugar or get their kids off sugar? Certainly parents have a difficult time when they're talking to their kids to try and explain the science of sugar consumption.
So I think the biggest thing is, if you look at it from the dopamine release perspective, if we're consuming a lot of sugar, our brains are tuned to want that same level of sugar to get that same dopamine burst. If you go from having a lot of sugar in your diet to having none, the experience of that change is really significant. Whereas if you slowly make changes within your diet, your crash from that dopamine rush goes down slowly over time. So it's not like, okay, grab all the sugar in the house and throw it out, because you're going to go into, the controversial sugar withdrawal, and then you might relapse, and then you're 2 pints of Ben and Jerry's in a couple hours later. It's those small changes, and they add up and they make a big difference. And so for me, when I went to college, I stopped drinking sugary sodas. And it was just kind of slowly over time. It was like all of a sudden I was just way more healthy, felt better. And it was just that slow change really makes a big difference.
Speaking of which, we've had a comment which kind of plays into that. Is that why new college students gain weight their first year? And I'll kind of rephrase that. Does sugar intake and consumption change with age?
Absolutely. So in the case of our bodies, it's all about metabolism. So how much energy is our body expending? Because that energy is us breaking down the energy that's stored in the glucose molecule into movement of our bodies. And so when we're younger, we're growing new cells, and that's highly energy intensive. So we need more sugar to stimulate that building of our body structure. If we're taking in too much glucose, then we have excess energy, and we take that and we store that in excess body mass, whether that's fat or excessive muscle, or you name it. That's kind of our body's process, is when we're getting too much of that energy, we're storing it because we're not just getting rid of it. As we age, though, our metabolism goes down because we're not building as much new tissue in our body. We're kind of trying to maintain what exists as long as we can. And so our ability to take the food in and turn it into usable energy just kind of decreases over time. And so we just don't have as much to maintain. Although there's probably some other metabolic processes going on within that. But that's a really great question.
Yeah, and thanks everyone at home. Keep these questions coming. Got another good one here. It says, as you've started to pay more attention to the sugar in your diet, what are the foods that have most surprised you besides almond milk and yogurt? Is there anything that might kind of shock people? We're not all great at reading the labels.
So the big one is alcohol. So alcohol is, and a chemist out there might be correcting me on this, but so I used to brew beer. And so with beer, what you're doing is you're taking those grains, you're breaking down the very large sugar chains within the grain into more simple sugars, and then you're using the yeast to ferment that and turn it into the sugar into ethanol. Ethanol gets used in the body similar to glucose. And so there's a lot of caloric intake that's going in, because in addition to the alcohol in something like beer, you're also getting kind of a sugary grain broth that is very similar to, or that is high in sugars. And so your body is getting way more sugar, even though beer doesn't taste sugary. And this is the case with like mixed drinks. I think, making margaritas, oftentimes you take that syrup, it is just syrup. It's sugar and water and like I think I was making a sour mix, and it told me how much sugar I needed to add to the lime juice water to like make the syrup. And I was like, that's twice as much sugar as it is water. Like, I'm gonna drink all that now. Oh my goodness. And so it's just for me, reading the packaging is really good because you can. So there's now in most cases they have to label added sugars. So it's not just about the contained sugars that's kind of naturally in whatever your product you're buying. It's the sugar that they add in addition to the natural sugars that are coming, say, from a fruit or a vegetable or something of that nature.
Speaking of added sugar, we've got a lot of people talking about ketchup. It's quite surprising. Presumably, there's natural sugars from the tomato, but there's cane sugar added and other forms of sugar. So another comment is when folks are walking down the cereal aisle, you mentioned it earlier in your presentation that they're more like candy.
I used to eat Rice Krispie treat cereal for breakfast. It was just Rice Krispie treats and cereal, and I look back on it and I'm like, yeah, like also there's this like myth of Captain Crunch that it like cuts up your gums so that the sugar can get into your bloodstream faster.
It's a bit like gold sugar.
Yeah. You know, it's so both of my parents work in the food industry. They're both food scientists. And my mom, for a little while, worked on the Hungry Man dinner line for Swanson's. And so when I was in college, she would ship me these kind of product runs, the white package. I don't know, it's too late for her to get in trouble for having me test those out. But then I think I kind of broke down the product label and was just like, oh, there's almost 3,000 calories in one of these products. And then the sugar's high, the salt is high, the fat is high. And when I talked to my mom about it, she said, well, she's like, what we need for a TV dinner is for it to last a long time and for it to taste good, because if it doesn't last a long time, people aren't going to want to buy it because it'll go bad. And if it doesn't taste good, they're not going to buy it because people like things that taste good. And she's like, making food that lasts a long time and tastes good is extremely hard to do. And you do that by increasing the salt, increasing the sugar, increasing the fat. And that really stood out to me as the conflict between the consumer and the company that's providing the food, in that if a company's just making healthy food, but people want the stuff that tastes good, they're not going to be able to survive as a company. And that it's up to the consumers really to essentially buy the things that they are healthy and that they want. But that's hard to do when we have a million things to do and stresses in our lives. To stop and think about what we're eating every night is really hard to do.
So we've focused on a lot of the negatives of a high sugar intake in the diet. What happens neurologically? What are the positives of a more balanced diet? What do you notice in terms of brain function as a neuroscientist?
So that's a really good question. I'm still just getting into kind of the digestion field, but I know one of the big things is the fact that we have a lot of nerve endings in our gut. And so oftentimes when we're stressed out, we can get stomach problems. And oftentimes when we get stomach problems, we get stressed out. And it turns into this chicken or the egg kind of process of, do our brains not feel good because our bodies don't feel good, or do our bodies not feel good because our brains don't feel good? And so if we're putting unhealthy, high sugar, high fat, high salt foods into our gut, that has an effect on those nerve endings that are sensing what kind of food's coming in. and that can send a signal to our brains. In that, the microbiome is kind of a hot topic right now. And so much of that is the interaction between the food that we're putting in and the sensations that we're getting from that. And so a high fiber diet, there's more kind of substance for the bacteria to hang out in and to kind of process into smaller bits. And that aids in the absorption of the nutrients into our bodies. And then we're getting more of that into our brains rather than kind of processing the food in more challenging ways with indigestion or gastrointestinal distress.
We're getting some great questions here, so we may run a little bit longer. Some of them you may or may not be able to answer, but for example, do hummingbirds get diabetes?
I have no idea. That's a wonderful question.
You're a neuroscientist, not an avian
ecology. I was about to say, that's fascinating. So, well, I think one of the things with hummingbirds is because they're expending so much energy to move their wings so fast that their metabolism is extremely high. It's like something like their heart rate is so high, and just the energy cost of running their heart to then move their muscle is just so high that when their net caloric intake is not very high, they just, it's almost in homeostasis, in balance with the amount of sugar that they're taking in. So for example, if you drink a Gatorade while you're playing soccer, that sugar is going to go into your body very fast, but you're burning it off really fast. If your body doesn't have that sugar readily available, it'll start breaking down other tissues in your body to get that sugar to the muscles at that time. And so you can imagine that for a hummingbird, they're always, at full tilt playing soccer. They can drink as much Gatorade as they want without the negative consequences, where if I'm drinking nothing but sugary Gatorade all the time while sitting on my couch and watching sports, that has a different effect on the body.
So if you work out like a hummingbird, you can consume sugar like a hummingbird.
Absolutely. Although there's still controversy around that as far as how much sugar you can take in, because there's too much.
Again, we're getting some good questions. Obviously, you're not necessarily in policy, but what kind of regulations are there for the sugar industry, and what kind of regulations could there be?
Well, that's a really wonderful question. And I think there's a lot of moving parts there because there's so many different stakeholders within the idea of policy making around food. And so you can imagine that part of the controversy around whether sugar is addictive or not. So if we classify sugar as an addictive substance, then do we need to regulate sugar in the same way that we regulate drugs of abuse like cocaine and heroin? And so if I'm a sugar producer, that would severely impact my business model. And so I would be invested in making sure that it does not get labeled as being addictive. Additionally, you can see why there's good reasons not to call it addictive, because it's not inherently a problem for everyone. It's maybe some people are more tuned into seeking more sugar because maybe they're stressed out and they're seeking more dopamine. And there's so many moving parts there that for me, it feels really good to be on the education side. Mm-hmm. So if I don't know that drinking a Coca-Cola has this effect on my body, I could just keep doing it without ever stopping to think about it. And then I have diabetes and I don't know why I have diabetes. I'm shocked because it's like, one thing about type 2 diabetes and type 1 diabetes is you can't look at somebody and tell. It's not a one-to-one correlation with body size and diabetes risk. Perfectly skinny people, or not perfectly skinny people, but very thin people can still get diabetes because it's not about our body mass. It's about our pancreas function. And if we're stressing out our pancreas, it doesn't matter. We're still going to lose out on the insulin and then suffer the negative impacts of that.
Okay, we've got about time for maybe two more questions. How quickly does a simple carb turn into sugar in your bloodstream?
So it's not doing it in your bloodstream, that's doing it in your gut. And so that's the big difference, say, between drinking syrup and eating an apple, is it takes some time for you to break down the apple into the little bits, that making it small enough to get into your bloodstream. Same thing with something like a complex carbohydrate, and like bread, it doesn't quite get broken down quite as fast as if you were to drink maple syrup. But then if you get that combination of maple syrup and pancakes, where you're getting the bread and it's a lot of sugar in a pancake, but I'm not going to stop eating pancakes anytime soon. So
finally, I'll leave you with this one. This is the kind of hard-hitting questions that we get. Do you have a favorite Ninja Turtle?
I Leonardo all the way. I think I always wanted to be Michelangelo, but I'm a Leonardo. Okay. Although the science side is like the Donatello always sounded nice, but Leonardo all the way. And as a kid, I used to get so mad at Raphael.
Well, Adam, thank you so much for sharing your time and expertise with everyone today. We really appreciate you.
Yeah.
And of course, thanks for everybody who's been joining us and watching for home, for all your silly questions, your thoughtful questions. We appreciate them all. We hope you've enjoyed tonight's event. Please send us some feedback. We've got a very short survey. It's only 8 questions, and that's in the description for this video. Also, if you like today's talk, it's going to be saved on YouTube. So share it with friends and family, anyone who you think might be interested in this topic. Remember to sign up for our e-newsletter, paxi.org/SITC, to donate to the Science Center at paxi.org/support. And we hope that you'll join us at the same time, same place next week for The Reality of War in Outer Space with Dr. Sadia Pekanen. So thank you, Adam, and thank you everybody at home. We'll see you soon.